Welcome back to the channel, everybody, and I want to show you another project that I worked on much earlier, roughly over a year ago, the Bat-Raptor. And at that time I was still learning some of this lighting technique, and I was using Light My Bricks as my source for all of these, well, these components for lighting. Incredibly expensive. They're supposed to be plug and play, well, they are, but at the same time you've got so many little connections and boards that it really wasn't plug and play, as they say, because some of these items required, well, a lot of configuration, and their wiring was very soft. It was flimsy, so you couldn't just cut it and resolder it. It was really difficult, and it wouldn't coil very easy, so you had a lot of excess wire. And then I got into fiber optics, and that was another learning experience, again on the Bat-Raptor, and I added this to the interior. It looks pretty cool once it's finished. I still have the video up there if you want to see it. Now this process is very tedious, very time consuming, and it's incredibly confusing if you lose track of what your wiring looks like. In this case, your fiber optics. But let's fast forward to today. Let me show you what I'm doing. So somebody saw the Bat-Raptor that I worked on earlier because I'm selling it on eBay, and well, nobody's bought it yet because somebody wants headlights. That's okay, I'll work on headlights. But I personally want to go into rechargeable battery. This is the components that I'll be using to add a rechargeable battery. It's the 4056 USB-C recharge board for LIPO 3-volt batteries. And this is really, really cool. It took me a while to figure out what goes together. This is the LIPO battery by Lighter Energy. It is a 1000 milliamp battery. It's a 3.7 volt, which is going to be handled by that board I showed you earlier. I will be using the quick connect wires and the switch from evandesigns.com. Totally different components. They're a lot less expensive, and they're from local US market, so the shipping is going to be a lot less than coming from Australia. Now, this is what I'll be using here. Remember to coil your wires before you actually solder them in. One quick connect will go to the battery to charge it, and the other quick connect will go directly to the board to then power the lighting that we need. This is the switch that we will be using for this project, on and off switch, and once again, coil the wires. I'm going to solder all this together into the board. I'll be right back. Now everything is now loosely connected to the board. I haven't soldered it yet because I wanted to show you these particular LED lights that are on the board itself. As you can tell, I have the USB-C connected on the left, and it does have those LEDs that light up telling you in red that it's charging, and it'll switch to a blue if it's fully charged. Because I have it loosely wired, it doesn't really recognize the signal, and it bounces from one light to the other. Now on the right hand side, you see the two loose cables that are hooked to positive and negative. Pretty simple stuff. That goes directly to your battery. I'm going to solder that. Now the two ports that are negative and positive on the far ends, left and right, they say out. That is going to go to the other quick connect to then power the lights that we need. Let me get that soldered in for you. Now I have everything soldered in just as I want it, because this is how it's going to go into the vehicle. I have my battery on the quick connect here. There we go. That's it. And I've spliced it in there. You can solder it however you like, or twist the wires, etc. That goes to those two center connectors, positive, negative. My switch that I was just holding on to is then on another quick connect, positive and negative, going to the other quick connect, and that's going to go to the lights. On this particular case, on the left hand side, you see a one single LED, and that's what I loosely tied in on the left hand side. You see the ends, I just twisted them in, coiled them in there. I don't have those soldered in because I'm going to remove it. Now, the USB connect is on the left. The switch is on the right here. And because I have that extra coiled wire, I can place it anywhere I want because I can stretch out that coil. Now, that LED is a breathing light, and I chose that one because I wanted to see the effect that it produces. So let's switch it on, and it's working. Well, we know it can handle one light because it's not really very much. It's only drawing about 20 milliamps off of this battery. And that's off of the spec sheet that's on the website from evandesigns.com. Again, this is a 1000 milliamp battery, so we have plenty of juice for this one light. But let's see if it handles 4 lights. And if you're wondering if I have a larger battery, I do. I have a 2000 milliamp battery, but it barely fits into the compartment. I just have to see if I can make this one work. If not a problem. I'll just add a quick connect to the other battery and then just switch out the battery source. And that's the nice thing about having the quick connects. You can switch out the different size batteries depending on the project you are working. So you don't have to have a large battery like this one. Again, this is a 2000 milliamp, the same company, Lighter Energy. And the one I have connected now is a 1000 milliamp, so just half the battery source. So let's take a look and see if it handles more than 4 lights. So I want to show you a closer look at that board and the soldering that's on there where those wires are located. I know somebody's going to ask, well, I didn't get to see it, it's too small. Well, here it is up close. The far ends are hooked up to the actual switch that I'm holding here now. The center connectors are going directly to the battery. Let me switch it on. And yes, it does power one LED just fine. Again, it's only 20 milliamps. Each light can draw about 20 milliamps according to the spec sheet on evandesigns.com. So let's switch it to a source of 4 lights and see how well that does. Now again, these are just loosely connected because I don't want them on here permanently, at least not yet. And I want to be able to switch it out. If you have a quick connect, then you can use that. I just didn't add it for this particular sequence. Again, this is a breathing light. It's got the actual programming in that tiny little chip that's in that sleeve, that black sleeve that you see there from the heat shrink. And it does everything on its own. There's no programming to do with these designs or Evan Designs. Now, switching over to 4 lights, and these are a little bit bigger. These are 3mm LED bulbs. Again, a loose connection going to the power source. Battery is already hooked up. The switch is ready to go. Let's see if it'll handle 4 lights. And yeah, pretty cool. I'm very happy with this. Definitely a lot brighter because they're bigger bulbs and they are certainly much brighter. However, I only need 2 of these and I want to switch out to different ones. Let me show you what I'm thinking about doing for this project. Now these I was going to use for the headlamps, but they're just too big and require a big opening for those lights. It's not going to work for me. Now, getting back to the actual board. Remember, I bought 10 of these. Because I bought 10 of these, I can use one as a spare to configure my location. And I've cut an opening in the back end of the vehicle just for the USB-C. I've cut an opening in the bottom for the switch. The switch itself has to fit tight, snug, not loose. The tighter it is, the better fit you'll have, that it won't fall out. Now, I don't have it glued in yet, so obviously it will fall out. But once you glue it in, it will be in there, well, permanently. And you want a nice snug fit so that when you switch it left and right, it has a good feel. And I placed it here because it's easy to find. So it's very low profile. You can actually choose where you want it to fit because you do have that extended coiled wire. So it doesn't matter. You have plenty of length of wire to place it wherever you need. I just chose to place them close together. Now the USB-C has to be in exact fit. So you'll have to mark it out with a permanent marker and only cut within those lines, and then very carefully use a file to round out those corners or your Dremel tool on the low power setting. Once you've glued it in and it's dry, then you can do a light test. And I'm going to choose a different light pattern here because I want to see how these lights would work for the interior. Now, I remember I used those fiber optics for the interior. Now I want to use a different light pattern. And actually, I'm using lights that are also from evandesigns.com, but they're made for a railroad model. And so these are traffic lights. And these are also pre-programmed. There's a set of 2, and they'll go from red, green, and yellow on their own without any programming. They're very, very tiny. And yeah, it's going to be just as tedious to put these in. Now, the nice thing is that they will be powered by this same battery. Let's take a look at how bright they can be. And I've sped up the sequence here because I don't want it to take that long in real time. So you'll see them change color much quicker. So moving forward, let me show you what you're going to need to make those perforations in that interior, and that's a small vise drill. You could use your Dremel, but if you have your Dremel on too high a speed, it'll just melt the plastic. Using this, you can control that speed and only drill out the plastic without melting it. Now, I can't show you because it's so small of a surface to work on. I'll just mimic this using the scrap piece of plastic, which is actually something I used from another project. And once you drill out your hole with that vise drill, you can then come in and make a divot with your Dremel using one of these bits right here. You just want to countersink it so you can then fill it in with resin and then place the LED on this. And now this would be the back side of that interior. The top would be this side. So in essence, you'll have this as a result. This is the underneath. I drilled it out. I made that divot so I could set that LED in place and it won't slide around. Then I secured it using UV resin. The blue tape you see is only to hold the wire in place. It's painter's tape. It holds really well. Now the UV resin that I placed coming in underneath creates a small lens at the top surface. And then I glue it in, or UV resin in that LED, and this is the result on the front side. Now remember that these lights are already pre-programmed and they will alternate the sequence automatically. I'm going to let you view it. I'm going to speed up the sequence so you don't have to bore yourself watching it in real time. They do take a while because they are traffic lights, but they look great for the interior. Now let's get back to the headlamps because those are a little more complicated. Obviously I can't show you everything here because it's such a small surface to work on and so cumbersome it's difficult to film it while you're working on it. But you're going to have to drill a hole at the top and the back, and you're going to have to fish that line through there. And fishing out that line takes a long time. You just can't see it. If you've got a better idea, fantastic. But unfortunately, this is the only solution I had at the time, and I may come up with another one later. But now you're going to have to run the line along the side. Remember, this piece slides in and out, and you want to cut a groove on the inside to be able to fish it out so it doesn't snag. And you're going to have to cut the same perforations on this unit that slides over it, so that you can fish out that line and bring it through to be able to connect it to your battery. If you don't cut out this piece big enough, it's going to be really difficult to fish out that line once again. Now, does the whole unit work? Well, the headlights at least. Let's run a test with those lights, and you decide, you let me know if it works or not. Now, I showed that last clip to the customer. He mentioned he didn't want warm white on the headlamps. He wanted bright white. However, those white LEDs burn at a different voltage. And this was too high because that battery is actually 3.7, and when fully charged, it's actually 4.2. And that's actually coming from evandesigns.com. I placed a call because these lights were heating up and they were melting the housing that I made for them. So I actually had to solve the problem with a resistor, and you'll see those at the very front. Let me bring those up close to you. Now, I'm not a lighting expert. I'm still learning. These are the resistors that I used, one for each headlamp, to tone down the voltage and bring it down to a 3 volt, and it worked really well. Now, once you feed the wires through to the back, a suggestion is to just go ahead and label each one of those wires, as they all tend to look the same. So if you label them, it will be easier to make those connections without having to guess. But if you've got a good memory, you know how to tell them apart, red and black, well, that's up to you. I would label them. It's just easier. Now, the headlamp lenses are made from UV resin, and then I embedded a piece of a metal screen inside that resin. Now it's time to paint the housing on these headlamps. Now, this is the paint that I'm going to be using on my particular touch-ups. You can choose any paint you want. I just choose this one because it goes really well over acrylic, or I should say plastic. This is acrylic paint. The key to this is masking. Project is complete. Let's take that Bat-Raptor for a spin. But before we do, I want to get you a close look at the switches I installed on the left and right side of the rear of the vehicle. The right-hand side will handle the headlamps. The left-hand side switch will handle the interior lights, plus the tail lights and the exhaust glow. And if you look at the upper left of your screen, you'll see the USB-C connected there. On the far right, you'll see a tiny dot glowing, which now just got covered up by the word charge, and that is indicating our charge indicator for the battery. Once it is fully charged, it will turn blue. And I used the fiber optic lights, or the fiber optic strand, to extend the lights to that distance so that you can tell when it is charging and when it is fully charged. This makes it that much more convenient instead of having to guess. Now, if you learned something today, or if you liked the video, I certainly hope that you liked the video, give me a comment or a like, and of course subscribe, because we got more coming. In the meantime, don't forget to keep customizing. We'll see you here next time. There's more coming on this channel. If you want to find out what it is, of course, you'll have to come back to the channel. Of course, if you subscribe, it'll make it that much easier for you. Just to give you an idea, I did work on this bat cycle over a year ago also. Now, since then, I have made several changes to this bat cycle, and I have documented that, and I've got the videos on my playlist for you to take a look. However, the biggest change yet is to make this cycle also with a rechargeable battery. If you want to find out how that was achieved, you'll have to come back and see the content. In the meanwhile, don't forget to check out my eBay and Mercari accounts for any custom figures you may want, or just some of the items that I'm getting rid of. I've got lots of fodder on Mercari, and one of those pieces could be yours to complete your custom figure. In the meantime, keep customizing. We'll see you here next time.